हाँ ठीक है, थैंक यू।
Okay. Good morning. It's good morning. No, it's good afternoon. Okay. So I will be taking today's class.
Good
And
afternoon, sir.
yes. So Saurabh sir is on leave. So he told me to do the graph theory parts. Like so, they have. I think he have already finished. Is it? So graph theory part is already completed. Yes or no?
Yes, sir.
Okay. So I will be doing revision. So we'll do revision. So I will also be asking you. So if you know, you can answer. If you don't know, you can say no problem. Okay. So first of all,
So the same MFC's class.
yes. What are you asking?
Same math class. Sir.
Yes, yes. Okay, so I will be starting with graph theory introduction. Like so introduction to graph theory. Okay. So in the graph theory, the first thing you learn. So what is definition of graph? Uh, can anyone tell what is the definition of graph? You know? So what do you know the definition of a graph? No one know
Sir,
definition of a
a
graph?
graph is an order pair.
Mm-hmm.
Sir, a graph is an order pair PE consisting of a non-empty set B or PG called vertex set and a set E or EG called edge set.
Okay. Yes. Fine. So if you write a definition, so graph is actually also said right. So graph consists of graph is actually this is so graph is actually order pair VE. Okay. Where V represents vertex set and E is edge set. Okay, so mainly like if you define in proper way, like in book, so they say that graph G is an ordered pair VE, okay, and consisting of a non-empty set V. Okay, so here V is vertex set and E is edge set. E is edge set. Okay, so V is vertex set and E is edge set, and where each edge is associated with two vertices. So like you have seen, each edge is associated with two vertices. So they are actually endpoints. So vertices are endpoints. So for example, if I make a graph, suppose this, these are vertices. So you may call it V1, V2, V3, V4. Okay, and suppose this I join. So this is an edge. So E1 is an edge, and it is E1 is associated with V1 and V2 both. So E1 is associated with V1 and V2 both. So we call them endpoints. So V1, V2 are endpoints of age E1. Okay, and so for example, for more if I write, so we have example like this. Okay, so if I join this and this, so this is V1, V2, V3. We call it E1, E2. Okay. So tell me, V, if I write capital V set. So V set consists of vertices. So there are three vertices here: V1, V2, V3. Okay, this is small: V1, V2, and V3. Similarly, E set here consists of like you may write E1, E2, E3, or you may also write E1 is oh sorry, uh, thank you. Yeah. So it's a E1, E2 only, not E3. Okay. So this graph has only two edges. Okay, E1 and E2. So like E1 is, you may write like V1, V2. Okay. So V1, V2. If you join V1, V2, then you get edge E1, and edge E2 is like V2, V3. So after joining V2 and V3, we get edge E2. Okay. So you may write this, V1, V2, V2, V3. So V2, V3, or V3, V2, if you write, it will work. You may write E1 as V2, V1. So that will also work. Okay. So for example, if I ask, so next example you have, next example we can write. So like I have written, okay, this is V1, V2, V3, and you may join it like this. So you may write, okay, like if I write vertex set, so vertex is say V1, V2, V3, and how will you write edge set? So we may name it, okay, E1, E2, E3, E4, like that. Actually, there are multiple edges between vertex V1 and V3. Okay, there are multiple edges between vertex V1 and V3. So that is E3 and E4. So you may write edge set consists of, edge set are E1, E2, E3, E4. Or if you want to write, you can write it even as V1, V2, E2 is V2, V3, and then E3 is V1, V3. You may write V1, V3 again. So it means you have multiple edges. Okay, and some other type of graph may be like, I'm making same type of graph. So this, and this. So it may be something like V1, V2, V3, and suppose I make this thing. So this is called a loop. So here the vertex set will be, so vertex set is V1, V2, V3, right? And the edge set, if we write here, so edge set is what? You may write E1, like this way, E1, this is E2, and this is E3. So E1, E2, and E3. And E, if we write, so E1 is what? In terms of vertex, if you want to write, so what you can write E1 as? E1 is same as V1, V2. You may write like this. E2, if you want to write, so E2 is a loop. So loop you write V2, V2. So means you have an edge between V2 and V2. That is a loop. That is called a loop. And then you E3 you can write V2, V3 like this. So this is called a loop. And there we had multiple edges. This two we had multiple edges, or parallel edges with multiple edges. Okay. We call multiple edges like this. Okay, so this is clear. In the graph you can write directly vertex set and edge set, and how edges are associated with vertices you can also write that. Okay, like I have written here. So E1 is V1, V2. Okay, E2 is V2, V3, like that. So this is fine. Okay.
Yes, sir.
So okay. Now if I write, like suppose we make a graph like this. This is one vertex, two vertex, V1, V2, V3. And so here the vertex set is like V1, V2, V3. But what is edge set? If I want to ask what is edge set here, so what will you write? in age set. So how many ages you have in this graph? हाँ, एज नहीं है, इसका मतलब क्या हो गया? The age set is empty set, so you will keep it empty. So this is called, a notation is phi, so you may use that notation. Phi is empty set. So E is empty, you will nothing write nothing here, so means it is empty set. So E is empty set, you can E is empty set, there is no age, so you will leave as it is. So E is empty set. Empty set means it has no element. Okay. So now, so I gave you the example of like loop here, na? So I told you from V2 to V2 there is an age from V2 to V2. This is called loop. And here you have seen like between V1 and V3 you have one age, and there are other age also. There is other age also, that is from V1 to V3 only. So means you have multiple ages. So now we'll write proper definition of that. So graph, you have seen graph is roughly you can say graph is an ordered pair VE, where V is vertex set, E is ordered, E is edge set. Okay, and every edge associates two vertices. Okay. Next we have, so what is, how will we define loop? Suppose we want to define loop. So what is definition of a loop? Can anyone tell what is definition of loop?
Can I?
Yes, yes.
The loop is connect to itself.
Right. So loop connect what?
Connect with itself.
So you can, yeah, you are right. So I understand what you want to say. But itself is what? So loop is an edge which have same endpoint, है ना? Which connect both endpoints are equal. So loop is what? An edge. So loop is an edge which has same endpoint, or which connects and start and end at the same vertex. Okay. So proper definition you can write is, so loop is an edge. So loop is an edge. So an edge whose end vertices are same. End vertices are equal, or you may write same. Okay. So both end vertices are same. In a loop, both end vertices are same. So an edge whose end vertices are equal. So we call it a loop. Okay. For example, like this I say, suppose this. So here you may define like this, you may go like this, this may have this. So in this graph, name it like this is V1, we call this is V2. Suppose this vertex here, it is the vertex. So here is a vertex, we call it V3. This is V3. Okay, and here I'm looking at loop. So arrow is not required because we are not studying directed graph, so arrow is not required. Here I gave arrow, so arrow is not required, so arrow we don't write. Arrow we take in directed graph, but we are not studying that directed graph. So in this graph, you have one vertex, two vertex, three vertex. So vertex set if we write, so it is V1, V2, V3. There are three vertices. Okay, and we write edge set. So we have edges. So one edge is this connecting V1, V2. One edge is this connecting V2 and V2. So that we call E2. And one edge is this connecting V3 and V3. That is called E3. So I'm writing, I have named it. So E1, E2, and E3. So you may write it like E1 you can write as V1, V2. E2 you can write as, so E2 you can write as V2, V2. Okay. E3 you can write as V3, V3. Okay. So E3 is V3, V3. E2 is V2. So those edges which have same endpoint, that are called loop. So here you can see E2 and E3 are loop, where E2 and E3 are loop. Okay, so E2 and E3 are loop. both have the same endpoint. That's why. Okay, so this is a loop. So loop is an edge which has same endpoint or same end vertices. How will you define parallel edges? Parallel edges, or your name is multiple edges. Parallel edges, or the other name is multiple edges. Multiple edges. So parallel edges or multiple edges. Okay, so can anyone define? How will you define parallel edge or multiple edges? Like you have seen one graph I have there, if we had there, right? Here we had. So if we want to define it, so how can we define? So how will you define parallel edges? Means what? You try to put into words. You know already. Everyone know already. So you put into words.
Multiple edges with same pair of endpoint.
Same pair of endpoint, right? So am I audible?
Yes, sir.
Yes, sir.
I think it has some problem with
Yes.
internet. Okay. 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 1 minute. So how will you define? So like ages which has same endpoints, right? So you may write in words like the book write ages with same pair of endpoints. So ages. So ages with same pair, है ना? Ages. Ages with same pair of endpoints. So we call multiple edges. Okay. So the edges with same pair of endpoint we call multiple edges. For example, so example like we had this, and suppose there is one more edge here. So you may write one more edge here. So this is V1, vertex 1, vertex 2, vertex 3. So in this, like you write E1, E2, E3. Okay. So this E1 have endpoints. E1 has endpoints V2 and V3. E3 has endpoints V2 and V3. So E2 and E3, E2 and E3 both have same pair of endpoints. So that's why E2 and E3 are multiple edges or parallel edges. Multiple edges, or you may write parallel edges. So parallel edges. Okay. So they are E2, E3 are multiple edges or parallel edges because they have same endpoint. E1 and E2 are not multiple edges, right? Because E1 has endpoint V1 and V2. E2 has endpoint V2 and V3, so they are not multiple edges. Okay. Next we have, so these are multiple edges. Okay. So next, if I ask what is simple graph, so what is definition of simple graph? How do you define simple graph?
Sir, a graph having no loops or multiple edges.
Right. So graph with which has no loops or no multiple edges. So without any loops or without any multiple edges. So we call simple graph. So a graph, okay. So a graph with no loops or multiple edges. Yeah. A graph having no loops or multiple edges. Okay. So graph which has no loops or multiple edges. For example, so I'm writing few graph and you have to tell which are simple graphs. So like question will, for example, if I write a question, so it will be select simple graph. So select simple graph. So like option A, if I give you a single vertex, B, if I write like this, C option we have, so C I will write here. So here we write this, and D, suppose this side, okay, and here, okay, let's make one more book. Okay, now not direction, so like, okay, so let me name it V1. This is V1 and V2. Here is V1, V2, V3, V1, V2, and here is V3. Okay, so tell me in the four options, maybe one more than one correct. Okay, so don't worry about that. So tell me which are, or which one, or no, so select the options which is a simple graphs. So tell me which graphs you is simple graph.
Sir, option C is simple graph.
Option C is, yes. Any more option?
No, sir.
Why option D is not simple?
Because they have loops and multiple edges.
Right, they have loop and they have multiple edges. Okay, this is wrong. Why B is not simple graph?
The loop है.
Right, here is a loop, that's why it is not. Why A option? So why A option is not a simple graph?
Sir, this is a point.
Right, so do you see any multiple edge here?
No, sir.
No. There is there any loop?
No, sir.
No, that's why it is simple graph. So it satisfies the definition of simple graph. So any graph which do not have loops or which do not have multiple edges are simple. So this will also be a simple graph. Okay.
Yes, sir.
So these two are simple graphs. So without loop and without multiple edges, if then it is a simple graph. So next we have adjacent vertices, or we call neighbors. So how do we define adjacent? So we want to tell adjacent. First we'll define vertices, like first this, or we call it neighbors. So what is the definition of this? Adjacent vertices or neighbors? So when do you define? When can you say
Sir, अगर सर अगर एक पॉइंट को कनेक्ट हो गया तो एडजेसेंट बोला.
Okay,
एक पॉइंट
connect.
को कनेक्ट.
So if you find any edge connecting these two vertex, so that two are adjacent or neighbors. Okay. So like if we find any edge connecting two vertex, then that two vertices are adjacent. Okay. So we write like if suppose V1 and V2 are endpoints of an edge. Okay. So if V1 and V2 are endpoints of an edge, then of an age. Okay, then v1 and v2 are adjacent, or you call it adjacent or neighbors. Okay, so if v1 and v2 are endpoints of an age, then v1 and v2 are adjacent, or you call it neighbors. Now, for example, so call it v1, v2, v3. Okay, suppose so okay, let's consider a simple graph, v4. So tell me adjacent of v1. So what are vertices that are adjacent of v1?
Sir, V2 and V3.
So v2 and v3. So I'm writing set. So v2 and v3. So because there is an edge connecting, okay, v1 v2, so that's why v1 v2 are adjacent. There is edge connecting v1 v3, so v1 v3 are adjacent. Okay, so tell me adjacent of v2. Adjacent of v2.
V1.
So only v1. Okay, adjacent of v3.
Sir, V1.
So it's a v1 only, and adjacent of v4.
Sir, nothing.
So no vertex, so you can write there is no vertex adjacent. So if I write, I'm writing set, actually set of neighbors, so that is empty set.
Empty.
Means there is no vertex that is adjacent, so I'm writing set, actually set form. So collection of neighbors, or collection of adjacent vertices. Okay, so next we have so neighbors view, like here you have seen v1 is neighbor of v2, v1 is neighbor of v3. Okay, so this concept are there, yeah. So this way you can write. So v1 is neighbor of v2, and v1 is neighbor of v3. So here v2 is also neighbor of v1, so this concept you can write. This way you can write mathematically. v1 and v2 are neighbors, v1 and v3 are neighbors. Okay, v4 is neighbor to no one. So next the term comes order of a graph. So next term is order of a graph. How do you define order of a graph? So what is definition of order of a graph?
Sir, order of graph means NG, or NG ka means number of vertices of G.
Okay, so order of graph is the number of vertices, vertices in graph G. So this is called order of graph, and we denote it by, so we denote it by n of G. Okay, so number of vertices in a graph is the order of the graph. Okay, so for example, if I write a question, so the order of graph, so let me make a graph. Okay, okay, so how many vertices making? So 1. Okay, you just have to count, right? Okay, so like this you may join like this. So this is the graph, and here is multiple edges. So what is order of this graph? So like options, if I make 1, 2, 3, 4, like that. So what is the order of this graph?
Sir, 4.
So you can simply see that there are 4 vertices. It's directly visible. So V1, V2, V3 and V4. So we have constructed a graph that has 4 vertices. So order will be 4. So just in exam, if they ask you order, just remember that what is order. So definition of order is number of vertices. You have to count the vertex. So the vertex you will count. There are 4 vertex. The order is 4. Okay. Next word comes size of the graph. Because this is the order of a graph. Now size of the graph. So next word is size of a graph. So how will you define size of a graph? Size of a graph.
Sir, size of graph means number of edges, e.g.
Number of edges. So size of graph means the number of edges in graph G. So the number of edges in graph G. Okay, the number of edges in graph G. So this is called size of the graph. Is called size of a graph. Okay, so for example, we make a graph like I was making, suppose like this. Okay, okay, and okay, so you just v1, I name it vertices, v2, v3, v4, v5, here I v6. Okay, so these are vertices. Now you tell me what is size of this graph. What is the size of this graph? So we write in a notation was E of G. Okay. Size of the graph. Okay, so size of graph each. So I may give you option. Five, 6, 7, 8. So what is size of this graph? You just tell.
6.
6. So how many edges you see here? 1, 2, 3, 4, 5, 6, 7, and 8. So how many edges you have? Edges you have to count.
Sir, 8
Number of.
is over.
You count it again. How many edges you have? This is 1. Is it?
Yes.
2, 3. Multiple edges will be counted twice. Okay, there are 2 edges here. Actually, I have used not simple graph. Okay, if you want to define in case of simple graph, then we can write that. So I'm writing in terms of I'm not defining in case of simple graph. In general, I'm defining. And then here is so if you make it simple, then it will be like if you want to remove it, you may remove multiple. Now you can easily tell like you're thinking. So 1, 2, 3, 4, 5, and 6. But there I have taken multiple edges. So this is also one edge. Sorry, this is a loop, and here is multiple edge. So you have to count. If we are defining, so depend on our definition. I'm defining in general. So number of edges will be size. So you just count the edge. In that case, this will also be counted. This will also be counted, and this will also be counted. If you want to make it simple graph, so you remove multiple edge, you remove loop. So now it is fine. So now you have 1, 2, 3, 4, 5, 6. So now you can write 6 if you remove multiple edges and loops. Okay. The size of the graph is number of edges. So mostly we study about simple graph, but not in general. So now I will ask you a few questions again. So based on these definitions, so we'll discuss some example or some question you can say. So suppose we make a graph. It's a very easy question you have already seen. So one by one others can also answer. So only. Okay, so I think everyone will try to answer. Okay, so I will ask your name. This time I will ask your name and then you have to answer. So I will ask the name of the person and then they can answer. So this graph you can see simply. So let's call it V1 or directly you remove it. Okay. So ask you number of what is order of this graph. So who will tell order of this graph? So let me start here. Okay, so you have email IDs here. So how will I know the name? So I have to take attendance and I have to see from attendance sheet. Okay, so anyone can answer, no problem. So I think this will be difficult for me. Okay, so anyone can try to answer. Let me go to that page. Yeah. So what is order of the graph? Anyone can answer. Yeah.
The 3.
Order is 3. And what is size of the graph?
So 2.
Size is 2. So order is number of vertex, size is number of edge. Next. So is it simple graph? Yes or no?
Yes, sir.
So it is simple graph. Okay. So simple graph because there is no loop and there is no multiple edge. Okay. Now so let's me name v1, v2, v3. So we may write in this way. So like I'm writing n for neighbors. So neighbors of v1. So what are neighbors of v1? Vertex v1. So what are
The
neighbors? Only v2. Yes. So here what are neighbors of v2?
V1 and V3.
So v1 and v3. And what are neighbors of v3?
V2.
v2. Okay. So yeah. So these are neighbors or adjacent you can say. So n means neighbors. I have written. So neighbors of v1 is v2 only. Neighbors of v2, so v2, v3 and v1 both. And neighbors of v3 only v2. Yeah. Next I have, so next example is, or the question I will write, that suppose let S is a set containing 2, 3, 5, 7, 9, 12. Okay. So that set S has these many members. 2, 3, 5, 7, 9, 12. 2, 3, 5, 7, 9, 12. So the question is construct a graph G such that a vertex of G is set S. Okay. And like AB, so A is one vertex, B is other vertex. AB is in edge set of G. AB in edge set of G if and only if, or it's not double F, so only if A plus B either belongs to S or modulus of A minus B belongs to S. Okay, belongs to S. And this holds for AB belongs to S. Okay, so now you construct the graph. So everyone please try to construct the graph. Okay, so you have given vertex set are set S. So like we were writing na v1 v2 v3 v4. So instead of writing v1 v2, write 2 3 5 7 9 12. These are the name of vertices, vertex set. And AB, so AB are two vertex, so that will jointly you will join, so AB will be edge. Okay, so like right now v1 v2 is an edge, so the v1 v2 collectively is edge, so edge joining v1 v2. So you construct a graph such that vertex set is same as S set and AB are two vertices that will make an edge. So that will be an edge if A plus B in S or mod A minus B is in S for AB belongs to S. So please construct it. So have you constructed, or if you have constructed, tell me how many edges you have. So the question is construct that graph and the number of edge, that is called size also, hai na? Size of graph each. So you tell me what is size of it. This is a numerical answer type. You tell me. So that numerically you have to tell. So how many edges that graph will have.
सर हो गया
काउंट करो कितने एज है उसमें.
और
So according to you there are 4 edges. Okay, चलो ऑप्शन ए रखते हैं 4 edges. ऑप्शन ए 4. हाँ, और किसी का कुछ और आंसर आ रहा है तो बताओ और ट्राई करो. क्या सबका ये आंसर आ रहा है? क्या सबका ये आंसर आ रहा है? देखो मैं ट्राई करता हूँ. तो क्या बोला इन्होंने? क्या होगा? सो वर्टेक्स कितने हैं? 2 3 5 से तो नाम देना है, ठीक है. दीज आर द नेम्स दैट वी वांट टू गिव टू द वर्टेक्स. सो लेट्स नेम इट वन वर्टेक्स इज दिस. सो इसका नाम 2 है, ठीक है. यहाँ पे चलो 3, यहाँ पे रखते हैं 4. नहीं 4 नहीं है ना. सो एस सेट में जो है वही रखना है. सो वी हैव टू exclude that, not 4. So 2 3 5. Yes, next we'll name सो चलो नेक्स्ट 6, ठीक है, नहीं 6 भी नहीं सर, 7 ना। सो नेक्स्ट नेम इज 7, देन 9 एंड देन 12। चलो, सो दीज आर वर्टिसेस, है ना, क्योंकि ये बोला वर्टेक्स सेट इज एस। एंड नाउ एज, ए बी विल बी एज। तो ए की वैल्यू सपोज चलो 2 है और बी की वैल्यू 3 है, तो बताओ 2 + 3 कितना होता है? 2 + 3 5। 5 है क्या इस एस में? एस में 5 है?
यस सर।
है, तो इसका मतलब है इसको ज्वाइन करेंगे, है ना। ये लिखा है ए बी बिलोंग्स टू एस। सो क्या बोला है कि इफ़ ए + बी एस हो जाए मीन्स यू कैन ज्वाइन। ओके, सो ठीक है। अब क्या है, चलो 2 और हम 5 को देखते हैं। सो 2 + 5 कितना होता है? 2 + 5 अरे ऐड
सर
करो, हम चेक।
7
7। सो क्या 7 इस एस में है?
यस सर।
सो 2 5 को ज्वाइन करेंगे। फिर चलो 2 और 7 के बारे में सोचते हैं। सो बताओ 2 + 7 कितना होता है?
तो 9।
9। 9 है इसमें, इसमें यस। तो बोला अगर ए बी
यस
इसमें है तो ज्वाइन करना है, ए को बी से ज्वाइन करना है। अगर a + b 7 है या a - b का मॉड इसमें है। सो 2 + 7 यस। चलो अब 2 और 9 को चेक करते हैं। तो 2 + 9 कितना होता है?
सर 11।
11 है क्या इसमें?
नहीं सर।
नहीं, तो ये फेल हो गया। लेकिन यहाँ पे दूसरा कंडीशन भी है, 2 कंडीशन है। देर आर 2 कंडीशंस, आइदर a + b बिलोंग्स टू एस और मॉड a - b बिलोंग्स टू एस। तभी हम 2 और 9 को चेक कर रहे हैं, ठीक है। अभी पहले है ना, तो 2 - 9 कितना होगा? 2 - 9 का मॉड कितना आएगा? 2 - 9
6
का मॉड, 2 - 9, 9 - 2,
सर 6
9 - 2 कितना होगा?
तो 7।
7 ना। तो 2 - 9 - 7 होगा, तो उसका मॉड लेंगे तो 7 ही आएगा। 7 इस सेट में है यस। तो 2 9 को भी ज्वाइन करना है, 2 और 9 को भी ज्वाइन करना है, ठीक है ना। अब हमें 2 और 12 को चेक करना है। सो 2 + 12 कितना होता है?
सर 14।
14 इसमें है क्या? नहीं। लेकिन 2 - 14 कितना होता है?
सर 14 -14।
2 - 12, 2 - 12 करेंगे तो 10 आएगा। -10 का मॉड 10 हो जाएगा। सो 10 इसमें है नहीं है, तो ज्वाइन नहीं कर सकते हैं, ठीक है। तो 2 और 12 ज्वाइन नहीं होगा। सिमिलरली अब 3 से स्टार्ट करते हैं। अब 3 के बारे में सोचेंगे। सो 3 है, 3 का 2 से तो हम लोग ज्वाइन कर रखे हैं, तो टेंशन। अब इसको 5 के बारे में सोचना है। 3 + 5 8 है। 8 है क्या इसमें? नहीं। 3 - 5 कितना होता है? 2। 3 - 5 2 है। मॉड ले रहे ना, मॉड मॉड है यहाँ पे, इसलिए मैं बोल रहा हूँ, है ना। ये तो a + b, सो a + b शुड बी इन s और मॉड a - b शुड बी इन s। कोई एक होना चाहिए, दिस और दिस। सो 3 - 5 का मॉड 2 आएगा, तो यस 2 इज इन s, तो ज्वाइन करेंगे। अब चेक करते हैं 3 को 7 से। 3 + 7 10, उसमें नहीं है इसमें। 3 - 7 4, 4 इज ऑल्सो नॉट इन एस, तो वो भी नहीं है, उसको नहीं ज्वाइन करेंगे। 3 का 9 से। 3 + 9 12, उसमें है यस, तो ज्वाइन करेंगे। फिर अब 3 का 12 के साथ। 3 + 12 15 नहीं है इसमें, और 3 - 12 9, 9 है, तो ज्वाइन करेंगे। फिर अब 3 का हो गया काम। अब 5 से। फिर 5, अब 2 3 के बाद नहीं जाएंगे क्योंकि 2 3 का हो चुका है। 5 का 7 से चेक करेंगे, है ना। 1 बाय 1 आई एम चेकिंग। सो जैसे 2 3 5 है ना, 7 9 12 है। तो पहले क्या किया मैंने? 2 को 3 से, 2 को 5 से, 2 को 7 से, 2 को 9 से, 2 को 12 से किया। फिर मैंने क्या किया? फिर 3 को 5 से, 3 को 7 से, 3 को 9 से, 3 को 12 से चेक किया। अब 5 की बारी है। 5 का 7 से चेक करेंगे। सो 5 + 7 12, 12 है इसमें यस, तो मुझे ज्वाइन करना पड़ेगा। सो है तो 5 7 ज्वाइन होगा। एंड 5 + 9 कितना होता है? 14, 14 है उसमें नहीं। लेकिन 5 - 9 कितना होगा? 4, मॉड लेके 4 उसमें है नहीं है, तो 5 9 ज्वाइन नहीं होगा। 5 और 12 कितना होता है? 17, 17 नहीं है इसमें। और 5 - 9 कितना, 5 - 12 कितना होगा? 7, 7 है, सो वी हैव टू ज्वाइन। तो 7 का भी, 5 का 7 से, 5 का 9, 5 का 12 से भी चेक कर लिया। अब 7 का चेक करेंगे 9 के साथ, ठीक है। अगले नंबर 7 9 7 12 चेक करेंगे। तो 7 और 9 ऐड करेंगे तो 16 16 इज नॉट इन दिस 7 माइनस 9 2 आएगा 2 है उसमें यस उसको ज्वाइन करेंगे। ऐड भी करना है या सब्ट्रैक्ट करना है, ऐड करके उसमें आ गया ठीक है, सब्ट्रैक्ट करके आ गया तो भी ठीक है, मॉड लेके। अब 9 अब क्या करते हैं 9 का 7 का हो गया ना 7 प्लस 12 नहीं है ना, अच्छा 7 का 12 सेकंड आ गया 7 प्लस 12 19 19 19 नॉट इन एस 7 माइनस 12 5 5 है यस तो ज्वाइन करना पड़ेगा, तो 7 को 12 ज्वाइन करना पड़ेगा। अब बचता है 9 का चेक करना सिर्फ, तो 9 का चेक करो 12 के साथ सिर्फ, क्योंकि 9 के आगे सिर्फ 12 बाकी हमने चेक कर लिया। तो 9 प्लस 12 ये तो 21 हो जाएगा, तो नहीं है उसमें 9 माइनस 12 3 है उसमें यस तो ज्वाइन करना पड़ेगा। तो ये ग्राफ आया। अब चेक करो कितने वर्टिसेस हैं, काउंट करके बताओ। So now you count it and tell me how many vertices you see here. Sorry, vertices पता है मुझे है ना, एजेस काउंट करने हैं 1 2 3 4 5 6 so 6 vertices I know, you count the age, so you count ages. Quickly count the ages. किसी का नहीं फाइन, काउंट करो कितने एज है, काउंट करो टोटल।
सर 11।
11 चलो देखते हैं, तो देखो यहाँ मैं करता हूँ 1 है ना, पहले 2 के साथ सारे चेक कर लेते हैं 1 2 ठीक है 3 4 ठीक है ये 4 हो गया 2 के साथ। फिर या ऐसे नंबरिंग कर सकते थे हम, एक मिनट नंबरिंग कर लेते हैं, तो नंबरिंग का मतलब 1 ठीक है यहाँ बाहर वाले पे देख ले या चलो 1 2 3 4 4 ये हो गया। फिर 3 से देखेंगे तो 5 6 7 ओके 5 वाला देखते हैं, तो ये हो चुका है 5 का 2 के साथ। तो आगे ये है 8 नंबर और 9 नंबर ठीक है 1 2 3 4 5 6 7 तुम काउंट करना ठीक से अपने नोटबुक पे लिख के। फिर हो गया 8 9 अब यहाँ पे आ जाओ, तो ये सिर्फ चेक करेंगे 9 के साथ, तो ये हो गया 10th ये 11th ओके। अब इसका चेक करेंगे 9 का, तो यहाँ होगा 12th ओके। बाकी हो चुका काउंट, ये 11 नंबर है ठीक है ना, तो देयर आर 12 नंबर ऑफ ages are 12, you count it again,
यस सर, यस सर।
so there are 12, so size of this graph is 12, so number of ages is 12, size of the graph is 12, this is the graph. So you can count in your way, how you can count, it's up to you okay. So 1 2 3 4 5 in this way you can also count, so you count in your way okay, that's all. So attendance कैसे लेते हैं सर, जब सर पढ़ाते तो अटेंडेंस कैसे होता है?
नहीं
हाँ मतलब
क्लास एंड
ओके इसमें अटेंडेंस खुद ही हो जाता है, लाइक यहाँ पे है ना, सो वी हैव ऑलरेडी पार्टिसिपेंट लिस्ट, तो आफ्टर ओके आफ्टर मीटिंग विल एंड इट विल सेंड द अटेंडेंस लिस्ट ठीक है, तो ये MS टीम में खुद ही अटेंडेंस हो जाता है, बिकॉज दे रिकॉर्ड तुमने कब ज्वाइन किया कब लीव किया ऐसा पता चल जाता है ओके। ठीक है, तो आज मैं क्लास यहीं ख़त्म करूँगा ओके, एंड थैंक यू एवरीवन।
थैंक यू सर।
Thanks.